Well, I guess I started a new video trying to focus. So, second one on the worksheet. Oh, it's not focusing. But it's N2H2. Hopefully you've done the worksheet and you're not just looking at this. So nitrogen has 5 electrons, hydrogens each have 1. So it's just going to form a double bond between the nitrogens and a single bond with each hydrogen. Symmetrical. Everybody has an octet, except, of course, hydrogen just has 2 electrons in its valence, which is what it wants. Then this, if you notice right here how this molecule is written, this is methanol, methyl alcohol. So it's kind of like the CH4 molecule, methane gas, that we looked at before, except one of the H's replaces an OH, which makes it an alcohol. You don't learn that till second year of college probably, so don't worry. So you're going to just plug in around the carbon with 1 hydrogen on each side, but then the oxygen will come in here and bond. That's why it's not written CH4O, because it wants you to see that this is the order. 3 H's around the C, and then the O is also around the C, but the hydrogen here is attached to the oxygen, not to the carbon. So all single bonds there, and oxygen has 2 unshared pairs. So this is an ion, and this is not something that you'll have to deal with. This says, as you can't see it, NO2 minus 1. So what you do, since it's a minus 1, it'll have 1 more electron than NO2 would normally have. So you just draw an extra dot somewhere that it fits in. And so you can see here, for the sake of symmetry, they did it like this, but in truth, it wouldn't really have a single bond here and a double bond there because the oxygens are both oxygens, so they have identical electronegativities to each other. So it would actually be like almost a bond and a half between each oxygen and the nitrogen. So instead of like single bond here, double bond here, you'd really have like that cloud of electrons kind of evenly shared throughout. And then you wouldn't ever have to do something like that in my class this year, though. But it's on the worksheet, so there you have it. This is not exactly what's in reality. This is sort of an approximation. You really have like a bond and a half. And then in this case, you have C2H4, which I think we actually dealt with earlier, to get a double bond between the carbons and then single bonds to the hydrogens like that. And that's a fun molecule. It can do all kinds of things, which maybe you learned about in biology. And then the last thing I wanted to talk about was ozone, because it's another one of these molecules where, like this, you don't exactly see the truth in the Lewis structure. You'd have to kind of think it through. So oxygen has 6 electrons around each oxygen atom. And so you would have a single bond between each of the oxygens, but then you'd have this unshared electron and this unshared electron. And so they kind of, since all 3 have the same electronegativity because they're all oxygen, they'd all kind of share. So you can see you'd have oxygen, single bond, oxygen, single bond, oxygen. Then you'd have like half a bond. These 2 unshared electrons, this guy and this guy, would just like float amongst the bonds, kind of being generally shared. So it would be like a bond and a half here and a bond and a half here. So those bonds in ozone are stronger than a single bond, weaker than a double bond. So strange molecule, but there you have it. So hope you had a great snow day. Sorry you have to watch all these videos. And I'll see you next week for the first part of Module 9. Please take the quiz proctored by your parents and the Module 8 test. Call me on the phone, email with any questions, please. All right, have a good day. Bye.